to Snark Chocolate, a show about ZK products where we break them down with rich flavors and sweet insights. My name is Omer, and I'll be the host for this episode. Today, we're thrilled to be joined by Sylve Chevet, co-founder and CEO at Hyli, the new proof-powered L1 to build the next generation of apps. Sylve, it's great to have you on the show.
Lovely to be here. Thank you for having me.
By way of introduction, can you tell us when did you start Hyli, with whom and why?
We had the idea of Hyli right after DEFCON 23 in Istanbul. We raised around in March, April 24, and so it's been about a little bit more than a year. And we started Hyli with my co-founder and CTO Lancelot, with whom we had previously built a company in the blockchain space on testnet before.
Sounds good. I'm curious. So you recently rebranded your name. What's the motivation?
The motivation for rebranding. So the sound is the same. We went from Hyli to Hyli, but we tweaked a letter. And the reason is because there was an ambiguity about how to pronounce it. It's a bit like my first name. People don't necessarily know how to pronounce it. So we wanted to make sure that we had something that people could easily read, parse, and understand. That was part of our strategy. If you want to build something global, you need to make sure that people can understand and pronounce it.
I also noticed that you have a very strong brand with the color orange and with this like orange theme in general. What's the idea behind that?
We really like Orange. Our previous project, we built an on-chain gaming protocol on Starknet called Brick. It was very orange as well, and we just vibe with the color. We thought that it was differentiated, and it was something that we enjoyed. And then we veered off towards the oranges, the tangerines. It was just good fun. We just vibe with the oranges.
Yes, amazing. I really enjoyed visiting your website and reading your material. I mean, it's coherent and I think you are doing an amazing use of the brand. So you recently launched a testnet. First of all, congrats.
Ooh.
Second, for those of us who want to build a new blockchain for whatever reason, maybe it's a good opportunity to kind of like get the 101 checklist for us beginners. What do I need to include in a new blockchain?
uh, if you've watched Game of Thrones, there's a character at some point who cures another, and it's not supposed to be possible because he goes through a very, very complex procedure. And people ask him, "Oh, how do you do it?" And he said, "I just followed the steps. I just followed the recipe." And it's a bit the same. Blockchains seem very intriguing and intimidating, but when you really um, slice the problems one after the other, and you really understand, okay, this part does this part does that. At the end of the day, it's still computer code. Computer code is understandable. Computer code is enhanceable. So we followed the recipe there. I think it may be useful to maybe backtrack a little bit about like how we, as you said, like if one wants to build an M1 blockchain in 25, you need to have some motivation. The reason for us to start this journey, which is quite daunting in 25, which is, okay, you're building an L1 blockchain from scratch, not reusing the Cosmos SDK substrate or anything else, just trying to climb Mount Everest from the north face. The reason we wanted to do this is because my co-founder and myself, we really fell in love with these zero knowledge proofs. We really were intrigued at their potential, and we felt that this was something that was completely worth over-indexing on. And currently, I mean, you're in the ZK space and the blockchain space for a long time. We go to great lengths to try and fit zero-knowledge proofs inside blockchains. And what we thought was, okay, what would it take to actually design a blockchain network around proofs? What do they need? What's necessary for builders that use them? What is missing? And so we started from there. We built an MVP using Cosmos SDK, and then we realized that, okay, we're going to be severely limited. For example, these tools are great if you want to add stuff. When you start removing things, for example, we removed signatures, everything blew up and nothing worked anymore. So we decided to really take matters into our own hands. And to come back to your question, how do you do it? we're able to do it with a fairly small team. We're less than 10 people at Hyli and 5 engineers, because the scope of what we're building is actually very limited and defined. If you look at L1 blockchains, they usually rebuild an entire proof system, runtime, an execution environment. It's very, very complicated. What we're doing is that because we're indexing over proofs, because we're making sure that proofs are the crux of everything we do, we only do two things. We have a very fast data availability and sequencing layer, and we verify proofs as part of the consensus. And that's everything that we do. So the scope is also very reduced. And once you do this, you start building an application, you test it in prod, you enhance over it, and at some point, 12 months in, you launch a testnet. So you can just do things.
I want to continue talking about the testnet a bit more. So you mentioned consensus and few other like pieces of infrastructure. Can you explain what you guys with your small team had to implement yourself from the ground up compared to and what you could just take and use as is or with minimal changes?
So the one thing that we are not rebuilding are proving backends, and proof systems. We rely on the existence of ZKVMs and different proof systems. We currently support SP1, RISC-0, and Noir. So this is something that we integrate. Hyli integrates the verifiers for these proof systems natively. So that's not something that we're rebuilding ourselves. Except this, we basically rebuilt everything. We used a couple of libraries like Tokyo, which is really, really good for networking. But apart from this, every single thing was from the ground up. And that means you need to choose, for example, your consensus algorithm. So here, we didn't reinvent the wheel. We implemented a paper of a consensus algorithm called Autobahn. We basically reviewed the literature and we thought, okay, what's state of the art? Because the basic idea of what we're trying to do is if you're building a blockchain in 25, like how would you do it? What are the tools that are now available that were not available in 2015, 10 years ago? And advances in BFT protocols and distributed systems mean that, okay, you can actually go much faster with consensus algorithms without risking failures or cascading failures. So that's how we ended up with Autobahn. And so I think the first implementation of this paper in production, what does that give us? It gives us a really, really fast DA layer. And it's also great for proofs because proofs tend to be pretty heavy. And if Autobahn makes it very, very easy for the network to recover or for different nodes if they don't have all data to really easily pick up the slack. So it just makes it very easy. So yeah, to answer your question, it's a lot of things at the same time. You need to rebuild an Explorer. You need to build an SDK. There's also all the tooling that goes around with it. It's a lot of work.
Okay, so taking one step back, what is actually the purpose of this testnet? What are you hoping to achieve?
There were two main objectives for us with this testnet. The first one was to really showcase that the system worked. And 72 hours in, we've generated 40,000 transactions, and I think we've done 15,000 proofs combined between RISC-0, SP1, and Noir, and that works. We had like several dozens of concurrent users on different applications. Every single thing was a proof. The consensus held up. It's geographically distributed over 8 nodes, so it was really an actual field test of everything because there are only two kinds of protocols, those who are actually working in prod and the others. So we really wanted to make sure that we were part of the first category. And the second reason was really to make a tour de force. There is a unfortunate tendency in the blockchain space to raise humongous amounts of money and not ship blockchains. And we decided to show that you do not need to raise 300 million and never ship anything, that you can do it with a limited team and you can actually do it better than them. So I'm not afraid to say that we go faster than Mina currently. And you can just do it.
Yeah, I love it. Kind of like a bit risky because if it would have failed, so you're kind of like proving the point that you do need to raise enormous
Exactly.
amount of money. But yeah, it looks good so far. I actually want to take one step, another step back because I
Hmm.
realized that we kind of like gave the title of like building a proof powered L1 for next generation of apps, and maybe it's good time to break it down. So the testnet eventually would become a mainnet at some point, and a new blockchain, a new L1. So what's going to be the use case, the usage or the use cases for this blockchain? What are you trying to build?
What we're trying to build here is the best and easiest way for any builder to build a decentralized application. Currently, the some options that you have is you build a smart contract in Solidity, then you deploy it on Ethereum L1, then you will be limited. It's the same old problem for the past 15 years, is that blockchains are just slow. And so we've uh, the ecosystem has went to great length to try and solve this problem by creating rollups, which are basically mini blockchains that roll up their state back to the big blockchain. And that creates another set of problems, which is now everything is faster, but nothing is interoperable, nothing works. And it's as if we had many, many different blockchains that talk with each other um, in a very difficult way, let's say. I mean, if you've ever used the Ethereum ecosystem and you have ETH over 15 different rollups, you know what I'm talking about. The model to build all of this is obviously that each application must be its own blockchain and has to compose with other application when it starts to make sense. And so what Hyli does is it gives builders the opportunity to build just this with a twist, which is that currently, if you look at rollups, if you look at app chains, um, they're blockchains. They build blocks, they operate as blockchains, and the programs that run on them are smart contracts. The fantastic thing that happened now that we have ZK VMs is that you do not need to build blockchains anymore. You can just build an application in Rust, host it on a server. The server generates a proof, sends it to the blockchain, and that's it. So it's a new sort of paradigm which just expands the design space for applications, which is just not limited to smart contracts anymore. There are different names, and the one that people seem to like most is verifiable application. And we're really, really interested about this because we do believe that if we are to actually put the banking system on chain, they're not going to throw away their legacy code and dozens of hundreds of thousands of COBOL code. They're never going to write Solidity. What they're maybe more partial to doing is deploying a server that occasionally sends a proof on chain. That's what verifiable applications give you. It's the easiest way to build an app while giving you the strongest guarantees of what a blockchain has. It's I like to compare it to Coke Zero. You get all the taste and none of the sugar and none of the drawbacks.
Yeah, that it's a good summary. But still, I mean, two things actually. One is maybe you can give a use case, a concrete use case. What do you mean by verifiable app? What do you expect to see on chain? And second is to tie it to the testnet. So what can be done today? And if at all, I mean, I understand that testnets, can mean many things. And here in particular, you wanted to try and check something very particular, but still kind of like interested because I haven't tried it. So interested to kind of like hear if users already tried it and what is their experience building these verifiable apps.
Mm.
Yeah.
To give a very, I have two very concrete examples for the type of applications that are only possible through proofs. One is you could have built a better FTX. The issue that you have with FTX and the massive hack that ensued was that what they were claiming they were doing was not actually what was going on, and there were withdrawals of money when there shouldn't have been. And obviously, this is not something you cannot run an exchange on the blockchain because transfers need to be confidential and private. So how do you combine um, the speed of a centralized exchange with the necessary the mandatory requirements of a blockchain? Imagine if FTX was running their engine and like had built their engine in Rust and were every 15 minutes generating a proof of every single balance that there is. And they don't even need to have everything open. You can just trust the proof that everything was going okay. And this is just fantastic because that means that you do not need to have hundreds of lawyers in your team in order to build something. You can just uh, trust the math. So it opens up a lot of possibilities for new teams to come in the centralized exchange space. So that's more like for very corporate use cases. The one part of where I'm actually very, very excited about zero knowledge proofs is the ability to onboard users. You have many different projects such as ZK email or ZK passport that basically mean that you turn your email or your ID card into a wallet. But it's very difficult to use on the blockchain currently. What we do at Hyli is that we make these ZK powered applications the first class citizen. So the future that we want to build is a future where I can just send money to Omer's passport. And he's the only one that can claim this because he's in possession of the passport. And that's the kind of thing that is incredible because it means that you do not need to onboard 7 billion people to the blockchain because 7 billion people are already on the blockchain. So that's the part that is it's more flexible for builders. And it's also fantastic for user onboarding because you actually don't need to onboard them. They're already there.
And what about today in testnet? Is there anything I can already do with existing testnet?
So we decided to have a very a different type of testnet experience. Usually when you see a testnet, it's like, oh, it's live, and then you have nothing to do. So we decided to really go the hard way, and we built an entire experience that we hope like will delight users. And every single one of these experiences showcases something about Heidi's architecture that is uniquely possible with it. So the whole story of the testnet is you landed on Mars and you are greeted by the first proof-powered life form, which is called the Hyligachi. And this little guy needs to stay alive by eating different kinds of tokens. And you earn these tokens by playing different games. And all these games are entirely provable. So for example, we built a faucet. This faucet is a ZK version of Fruit Ninja. So you just slice oranges on your phone, and every single one of these slices is a transaction that is going to be proved and will send you a token. Every one of them. So that's what that was one of the reasons why we generated so many proofs. And I'm terribly sorry for the RIS0 and SP1 people because I think we sent them a gazillion amount of proofs. And every single thing that you see on the screen is actually proved, verified, and it goes super fast. So that was super cool. And we built a couple more games, so I'm not going to spoil absolutely everything. And the incredible thing is that we built these games in like a couple of days, just because it's very, very easy to build an application in Rust versus in Solidity. So yeah, that's just really cool.
That's so cool. Have you used AI vibe coding for the apps?
Mostly
Partly?
for front end stuff. So we'd like to thank our Claude intern for doing the front end of most of this. And this has tremendously sped up our speed of execution. And I don't think it would have been possible for us to use AIs that much if we were not using Rust and ZKVMs for the backend. That would have been much more difficult.
You mentioned that you're sorry for risk zero and the same for sending them proofs. Can you explain this? I mean, and even it's something that bugged me a bit also earlier when you mentioned that the prover part is kind of like the only thing that you just like take from someplace else. I mean, why not own it? And also, what does it actually mean in the context of the test and sending them proof? Like they also have some kind of like a testing environment in which you can just like send proofs and they like produce the proofs.
So I think it's interesting if I explain a little bit more about how applications work on Hyli and compare it to something that maybe people know better. If you have a smart contract on Ethereum, the way it works is you send a transaction to Ethereum and you're basically telling Ethereum, okay, do this, perform this computation, uh, and Ethereum will spit out a result and update the state of the application. The way it works on Hyli is that transactions are proofs. So you just give the new state to Hyli with the corresponding proof, and Hyli says, yep, that's the new state. That's a correct proof. So I will update the state of the application. So yeah, the bottleneck for blockchain is you need everyone in the network to do some computation. And very quickly, people who stumble upon this problem, which is a problem that we've had for 15 years in the blockchain space, is, why don't you just have bigger blocks? Why don't you just use bigger computers? And the reason you don't use bigger computers is because if you do this, only the big computers can participate in the network. So you get very, very limited in terms of decentralization options. But it would be really, really cool if we could have the supercomputers do all the hard work and have a way for smaller computers to verify their work. And that's basically what proofs allow. They remove the burden of execution from the blockchain. And so the blockchain just needs to verify the work of other computers. And that's uniquely possible because of zero knowledge proofs. And that's why we've decided to have this architecture for Hyli, because we firmly believe that this is the only way to actually scale blockchains. So that's how applications on Hyli work. Um, Users send their transactions, they get proved, and then they get verified on Hyli. And so applications need to use different proof systems, proving network, or proving services. So what we've done for the testnet is that we partnered up with Succinct and with Zero for different applications. So the little server that runs the application is just constantly pinging them to request proofs, gets them, sends them to Hyli, and Hyli verifies them.
That's very nice. So staying on this topic of partnerships, um, who else have you partnered with? Just curious.
So we've partnered, not going to list them all, but there's a handful of them: ZK Cloud, Sindri, formerly known as Givelot, with Zero, SP1, Firma. Our main partners are proving systems, proving networks, or proving services. The reason is that the equivalent of block builders for Hyli are people who can generate proofs. And so we need to make sure that builders that build on Hyli are able to access them. And so currently for the testnet, we prove everything ourselves. We take care of the proving by requesting it to Succinct and Zero. In the future, users will just send the transactions over to Hyli. Proving networks will look at Hyli and say, oh, I can actually earn some money by proving these different things, generate the proofs, and send them over to Hyli.
So you are gonna work in some harmony with the prover networks, the new ones, and the marketplaces, right? That's kind of like the idea.
Absolutely, yeah. We need them for the network to work, basically.
Yep, got it. So diving a little deeper into the tech stack. So we know that there's the Rust. We know that ZK proofs are essential. I guess that after naming all these partners, you guys probably, from where you stand, you have a very good view of the entire ZK industry as a whole. And I'm interested to kind of like get your take on where we are, like in I don't know, in terms of adoption, in terms of like performance, user experience, because I mean, you're solving something which seems to be very critical in one way. But again, like from your point of view, you should like have a good feel about like all the parts of the tech stack around ZK. So interested, maybe you have some insights about where we should improve, um, where developers should invest more time, where demand is coming from, and so on.
When we started Hyli, we had conviction over two trends. One was that the tools that were available for developers to work with proofs were constantly improving. And we're originally from the testnet ecosystem, so we started out with Cairo, which was already a massive improvement over everything that existed before. And with the advent of ZK VMs, for example, that was another very, very big step in the right direction for usability of proofs. It used to be that even 7 years ago, even 5 years ago, you needed to have a PhD in cryptography to do any of this. That was actually one of the the reason the Stockway team ended up building Cairo because they were doing all their circuits by hand, and then they realized, oh, we could generalize this and maybe have a language that allows us to express this. So, um, one trend that is incredible is that the tooling around these proofs are getting so much better. And second, the proving speed is just going through the roof. And that is one thing that hasn't stopped for the past years. I think it may be the only thing in the blockchain space that was ahead of schedule and way ahead of schedule versus what we were all thinking. We're reaching territory where with $100K worth of GPUs, you can prove Ethereum blocks in nearly in real time, and that was completely unthinkable some years back. So that's the part that is just great. And ZKVMs honestly have to be commended for really opening up the design space for these different applications. The part where I think it's still a little bit lackluster in the ecosystem as a whole is for everything that relates to client-side proving. So in order to generate a proof, you need to have a computer that is going to generate the proof. Usually, this is done on a pretty beefy server hosted in the cloud, or even with what you folks excel at Ingo, which is hardware acceleration, because it's just cool, because you can trust the proof, you can use great hardware and go very fast. But sometimes the proof must be generated by the user on their own device. And that means that you cannot use all these different tricks. And so, for example, we run a lot of benchmarks around all the different options that you had in order to generate proofs client side. The use case for this, for example, is I want to generate a proof that I'm a French citizen. I want to generate a proof that I'm over 18 in order to access a DeFi protocol, for example. I cannot send a picture of my passport to a proven network. I'm not going to do this for privacy reasons. So you need the proof to be generated over there. So on the user device. And the issue that you have is that you don't have a lot of power, you don't have a lot of memory, and it becomes very difficult. So we run the benchmarks, and currently the best option is to use a language called Noir, which is developed by the Aztec team. And that's one of the very, very cool affordances that we have at Hyli, is that you can combine all these different proof systems for the thing that they're really good at. So some of our applications, for example, are 95% with zero because it's easy to use and you don't have any constraints over privacy. And 5%, which relate to user identity, are built with Noir. And you can just use the two proof systems without even thinking about it. It's as if you were using different smart contracts. So we are firm believer that client-side proving is going to get faster, tools are going to get better, and proving speed is just going to keep on increasing. I think the next big step will be in everything with client-side proving.
It's very interesting. I read one of your blog posts. I think it was by Vlad the Magnificent about benchmarking, and specifically, you wanted to benchmark client-side proving for digital signatures. Now, this is like very specific. What was the motivation to? I mean, I think you just explained about client-side proving, but what about digital signatures?
The To come back to something I was saying a little bit earlier about what is uniquely enabled by proofs, and I was talking about the fact that it's very easy to onboard users. The way you do this is because users already have ID cards, passports, and these documents are signed digitally by keys that are held by the government. And you can have a very, very high level of trust in these keys. One thing that you would like to have, for example, and it's an actual situation in France where um, adult websites have been banned until they put in place measures to make sure that minors cannot access the website. So you need to prove that you're over 18. And it's actually a really, really good use case for ZK. So we know some friends of ours who are actively lobbying to make sure that the French government looks at ZK and says, oh, that's actually a really, really viable option and a privacy preserving one on top of this. But in order, so the end goal, what you want to have is an API from the government that any website can query and ask, is this person over 18 in a privacy preserving manner? The issue is that there is no API to do this. And maybe you want another API that says, oh, I'm 18 and I'm French, or I'm 18, I'm French, and my first name starts with the letter S. You want to have a permissionless composability over signed statements. And that's basically what ZK gives you. So you have your ID card, you have a bunch of information over it, and you can generate a proof of a subset of that information. So with my passport, and I'm at Zoo Berlin right now, the ZK passport team is also here. So they built a system that allows you to generate proofs that you're over 18, that you're from a certain country, straight from your passport, straight on your device. And the reason we run this benchmark with Vlad is because the signatures are with a specific signature scheme that is always the same. It's SEC P256R1 or P256. So you need to be able to generate a proof very fast on user devices. So that was the reason why the benchmark was so restricted, is because in our mind that is the best use case for client-side proving at the moment. So dear Vlad looked at absolutely everything. He looked at Circom, he looked at Halo 2, he looked at Noir, he looked at the ZKVMs, and Noir came out on top in terms of usability, speed, and memory usage. It was just the best option at the moment.
Yeah, I think actually this kind of restriction is maybe the reason why you were able to get such a clear data point from this research, which is great. Like we need these data points.
Absolutely. I like to think it's a little bit
yeah.
like the ETH proofs time to prove Ethereum blocks, but for client side. I think it's more telling that than proving Fibonacci numbers.
Right. Okay, so one thing I wanted to ask is about your upcoming roadmap, next milestones and so on. So now you have a testnet, it's live. What are the next steps until mainnet?
So we didn't want to have a testnet which was about, oh, build it and they will come. We took the decision to actually build a lot of things ourselves to really show what was possible to build. So we built a ZK-powered wallet. You prove that you know your password, generates a session key. The UX is really, really cool. And the rest of the work for us in the next three months will be to really make sure that everything that we have built for the testnet is productized, can be used by other developers to really expand upon the work that we've done. We've realized that the architecture that we have is very, very powerful, but it's only as powerful as the number of people who can use it. So a lot of our work in the next 3-4 months will be to onboard new developers, make sure that they can deploy their own verifiable applications on the Hyli testnet, with the objective within the next 18 months to actually hit mainnet.
Looking forward. This sounds all super exciting, and I'm really eager to try it out myself and see what you guys have built over the last year or so. And yeah, hope that we can chat again and discuss some of your progress. Before we go, there's one last question which we ask all of our guests, which is to name a project you are bullish about.
I have a weird answer, but I'm pretty bullish Zcash, because there was the privacy coin, because there recently was an announcement by one of their researchers that they may have found a way to tremendously speed up the network and reduce the load on the nullifier trees. So that was a very, very exciting news, and I'm excited to see more ZK first protocols really push forward with innovation. So yeah, I'm gonna say bullish Zcash.
It's a great answer. Yeah, and with that, Sylvie, I would like to thank you for joining us today from Zoo Berlin. It was great to learn about the progress you guys are making at Hyli. We'll share some links in the show notes for anyone who wants to follow up. And yeah, thank you again.
Thanks a lot, Omer. Thanks for having me. Cheers.